Hello, hello everyone. Today I'll be showing you guys how to train a machine learning model on Replit since now a new feature is being offered, and that is of GPUs, which help accelerate the deep learning process and make it a lot faster. And I'll also show you how to host a machine learning model using Flask and Python uh, very easily so that you just have to use the same code when you need to use the model elsewhere. So I'll just check if my audio is working. Just a sec. Okay. Yeah. So first of all, why do we even need a GPU? And how does GPU exactly help in the deep learning process? So a GPU is essentially a graphics processing unit. It is a special purpose processing unit that processes graphics Yeah. So essentially, what it does is it helps in processing matrix operations a lot faster than on the GPU, than on the CPU. So that's why for a lot of machine learning tasks, the NVIDIA GPUs are used nowadays. So the GPU that Replit offers currently is the Tesla K80 GPU, which is pretty good actually. So, if you're planning to train any deep learning models, uh, it should make it a lot faster. Oh, so my voice is breaking. I'll try to fix that. Should be a connection issue. Yeah. So, the first model we are going to take a look at is the cycle GAN. GAN standing for Generative Adversarial Neural Network. And the cool thing about this deep learning model is it's essentially a type of style transfer, but you don't really need two data sets which depend on each other for the model to learn their own properties. So, for example, let's say you want to convert a painting to a realistic photo and a realistic photo to a painting. So you're essentially just transferring styles, right? But the main thing about this model is the cycle GAN. So the cycle is in that sense that for the painting to the photo, it does not really need a data set which has exact corresponding images, right? For the example painting, it need not have the exact photo for it to learn the style which it has to learn, right? So you can have a data set in which it has a couple hundred photos of paintings and of realistic landscapes, and it will learn the styles of both those data sets, and then you'll be able to cycle through. uh, it's a simple GAN network which I'll be showing, and I'll also be showing how to train that with the GPU. So yeah, first of all, if you need to choose a deep learning model, there's a lot of them. All you really need is the code and also the data set. Currently, the only issue with training a machine learning model on Replit is that Replit has a storage limit of 1 gigabyte. So the data set that you might have might need a little more space. So that's the only issue. But otherwise, if you're, let's say, like training the cycle GAN, right? So if we look at the data sets, most of them are under a gigabyte. But if you want to go for a maps data set, like for example, this one, I guess it doesn't have an example. Yeah, it has an example here. Yeah, so something like that, uh, like a general map, and it outputs as a realistic city map, something similar to that. That might need that might need a little more storage. This one. So other than that, if you want to do a transfer of styles from paintings to photos or summer to winter, and these are different kinds of paintings like Ukiyo and Van Gogh, uh, cityscapes, all these data sets are under a gigabyte, so you can use those. So here what I've done is, this is the code for the GAN, and this is the training process, and I've trained it for a couple of epochs. So if we see in the beginning, it will look a little muddy, yeah, like this. So because it has only been trained for a single epoch, so it isn't very good yet. But if we take a look at, say, 176th epoch, till then the model would have a pretty good idea, and it would have learned a lot of properties like this, for example, or 177. So we can see, uh, this is the painting, this is the model's conversion to a real life landscape, and this is the reconstruction of the model based on its construction of the landscape of the painting. So you can tally these and you can see how accurate this is. You can also check the losses. I plotted the losses here, this. So if you train this on a normal CPU, it would take a lot of time, because image processing as a whole is a very complex task for which GPUs are much, much better than CPUs. So to enable the GPU on Replit, you need to first off go to your account, and then you can click here on the account. And if you go to the bottom, there will be a tab of roles, and you need to enable Explorer. Once you enable Explorer, you'll get this option in any REPL that you open to enable the GPU. GPUs are currently in the beta, so uh, if you enable the Explorer tab, only then you'll have access to the GPUs. So you can access the GPUs for a couple of cycles. Yeah. So currently you can use the GPUs for 375 cycles per day and per REPL. So if you enable it on one REPL, that's the only one you can use it on. So yeah, if you want to train something like a GAN, you can do that. And then once it's trained, you can save the outputs, uh, you can save the model, and then for hosting it, you can host it in another REPL in something like a Flask app, which provides basic hosting, and you can just make an API call from your website with the link, and get the output image. So yeah, as we can see, I've put it on training, so it slowly keeps on improving, and it keeps saving the result of each epoch as its own image, so we can see how it improves over time. So in the first epoch, we had a really muddy image. In the 177th epoch, it looked decently realistic. in the actual paper that they published, they trained the model for 200 epochs. So that would take a couple of hours on a GPU, but it would take days easily on a CPU. So as we can see by the sixth epoch, it's trying to get an idea and it slowly improves over time. So that's how you can enable the GPU on your REPL and train any model that you want, given that the dataset is under a gigabyte. Also, if you're wondering how you can get the dataset inside the REPL, you can just copy the link and do a wget in the shell. So wget will essentially just download whatever is in the link that you've provided. Simple as that. And it will get saved in your directory here. Okay. So next thing that we can do is see that once we have made a machine learning model, how we can actually host it. Yeah. So I'll be showing you guys a simple linear regression model and how you can host that. So for that, you can create a new REPL and choose the template of the Flask app. So initially you'll get this file main.py and it will be configured to return this string on the root of the website. So you can edit this to essentially output the result of the model. You can output the result of the model which you have trained in a separate REPL with the GPU. So yeah, let's just first of all make a simple uh, synthetic data set, for example. So for that, uh, since we're doing linear regression, we can have a data set which has linear values just for demonstration purposes. So, so we import numpy and then matplotlib so that I can show you guys the plot. Then we can just generate a random set of data. Let's say 100 items, and we can put y as any value. Same 100 values, and divide that by 10. Otherwise, the random values will get added, and if they're really big, then the plot will no longer be linear as the randomness would be too high. But if we divide it by 10, then the randomness is just low enough to still be linear, but high enough to not just be a straight line. Then do that and you can save it. Then we can go to the shell and that. Okay. Yeah. So you can see this will be a linear regression dataset which is synthetically created. And if we make a model to on this dataset, then we can create a Flask app just to see how we can make API calls to a pre-trained machine learning model and serve the output in the JSON format or in a simple list format. So to make the model here, import NumPy again, then import linear regression. Then we have the data already, so we can just take that from here. When we create the model, yeah, then we create the model and then we fit the model to the data set that we have created. And to save the model, we'll need to import pickle. You can save it in model.pkl. We open it as WB to write it in the binary format. So that should fit the model and save it. Let's try it. Okay, so the linear regression is not callable. So for that, let's check our imports. Import the linear model, linear regression, import NumPy, import pickle. Dataset is fine, model is fine. Yeah, model.fit, right. That works. So we have the PKL file, which is in the binary format. So now uh, the PKL file is just used to store the model so that when we start the Flask server, we can load the model from the PKL file and then use it to serve the outputs, which is also pretty simple. Uh, import NumPy, then we just need to load the model from pickle. The name of our model, initialize the Flask app, and then let's create one more route. We'll name it predict. So let's complete this function then. Also, this function will not be a post function. Instead, it will be a get function, since first we'll get the data as the input and then we'll return the output of the machine learning model. So first, to get the data, we can do request and we get the argument as the name of input. I'll show you guys an example of that once we complete the function. So If you want to see what the data is, you can print it. Otherwise, there's no need. Then we convert the data into an NP array, and we make sure we convert it to a float, since by default this returns a string. So then we get the prediction, model.predict, and data.reshape, and this one, because we gave a single input of one element, and we do a -1 so that it changes from a row form to the column form. That's how the model takes in the data, and the prediction will be in form of a numpy array. So we return prediction and dot to list. Since we cannot return a numpy array, we can return lists, tuples, dictionaries, or something in a JSON format. So this is a Flask. We get a few errors. Let's see. Okay, so the error is in predict. Unexpected keyword argument of method. Okay, so it's not method, it's methods. That should work. Yeah. Let's see if the root of the website returns the string welcome to the live stream. Yep, the root of the website works. So now if we go to predict, and and to give an input, we use the question mark, and then whatever variable that we are providing, that we get from the request arguments here, we write the argument name, which is input, and then equals the value. If we want to add multiple arguments, we can add the ampersand symbol like that to have multiple arguments. So let's go with 0.5, and we get a predicted value that a machine learning model has given to us. We can go for any value and we'll get the prediction of a machine learning model. So if you are using this in a web development uh, environment, so one might assume you have set up Node.js and you're working with JavaScript. So uh, in your website, in the front end, to show the contents, let's just say, uh, looking back at the cycle GAN that we talked about earlier, if we save the machine learning model here, we can serve it as a part of a website using the Flask API, in which the user uploads a photograph, and then we give that photo to the model. The model gives an output, and we show that output on the website. So that's how you can do the entire process on Replit. First of all, you can train a deep learning model, then you can save it. Once you've saved it, you can download it and then present it in a Flask app, which is pretty simple to make. Since I showed you how to make a Flask app, yeah. So that's the entire process. Hope you all learned something new. And yeah, that's it. Let me know if you guys have any questions. I'll make sure to answer them. And yeah, that's it. Thank you.